Hey there, friends. I've got my Back to the Future look back from the future. Remember, a technique in Martian math is like we're colonizing Earth coming from Mars. And that makes no sense at all, but I'm basically think of humans having technology high enough that they did get to Mars. They have been living there for a while. What would the benefits of that program be on Earth? Like, how would that help us terraform Earth? And I think we can sort of project ourselves into the future and look at the Earth as a challenge where it's humanity on planet Earth. I like that we worry about climate change because that's a global issue that we can all get together on. I think climate has changed, and I usually say the biosphere because there's so many more factors than like temperature to care about, right? Gibbs phase rule. So I'm back to data science, and I just wanted to say a few more words about artificial intelligence, which was a theme recently, a couple vids ago. Now, this Royal Institution video where Chris Bishop talks about AI, he goes through the usual analogy, which is to use neurons like perceptrons, and supposedly the computer that does deep learning is modeled after the human brain. Well, you could say that. But as a Quaker, I'm familiar with like committee structure. So I think more like a skyscraper where the CEO at the top is the one who has to have it right. And so these committees make decisions on the ground floor, and then they each send a delegate to the next floor up where they have more committee meetings. And when they finally do get to a decision, then that's when we kind of say wrong or right. And we reward, going backwards down the tree, we reward committees that got it right. You know, we slightly boost their credibility. Slightly, right? This is called gradient descent, and there's actually some calculus going on. There's sort of a downward pressure to get the committees to get it right more and more often. They have to have what? They have to have feedback. So that's what this loop by Hinson, the Toronto University group that finally got this to work pretty well and gave us all these breakthroughs in speech recognition, image recognition, basically pattern recognition of many kinds, thanks to deep learning. You could talk about how that's a neural thing going on, and most people do, but I'm saying also a skyscraper with committees all the way up to the top, trained to slowly improve based on many, many, many case examples, right? You kind of start out with a completely random response when you're asked to judge something, and then you get the feedback, and it's a tuning of like tuning a violin, or I think of like blasting water through a canyon, and over time it takes shape. Anyway, these geological metaphors where vast amounts of examples are pumped through the system, and lots and lots of linear algebra. So the analogies matter. You can model it after the human brain or any brain if you like and say it's like biological. But really, because it's mathematical, we are not really tied to biological metaphors. So AI does not have to say it's imitating the human brain. It's fine to do that, but it's not required. So that's just another thing I wanted to throw out. Talk to you again in a little bit.